Just take a look around. Think about the phone in your pocket vibrating, or those giant robotic arms you see on assembly lines. Our world is just buzzing with motion, right? But what's actually making all that happen? What's the muscle behind the machine? I mean, really think about it. Ever wondered how your car's power window just glides up and down so smoothly? Or what gives a robot arm the crazy precision to put together something tiny, like a smartphone? The answer is actually the same for all of them, and it's pretty much the secret to how our whole modern world moves.
Okay, so the secret? It all comes down to this incredible family of devices called actuators. And they are everywhere, in all sorts of shapes and sizes, but they all do one thing, one fundamental thing. They create movement. You could say they're the true unsung heroes of motion.
All right, so let's get into what an actuator actually is. At its heart, it's basically a converter. It takes some kind of energy, could be electricity, could be fluid pressure, whatever, along with a little control signal, and boom, it turns that into real physical movement. It's the link between a command, like move, and the actual action.
So you can imagine there are a ton of different kinds of actuators out there. So how do we even begin to sort them out? Well, luckily it's pretty simple. We can classify them based on two key things. First, how they move, and second, what gives them their power.
Okay, first up, let's talk about the motion itself. An actuator basically moves in one of two ways. You've got linear motion, that's just a fancy way of saying it moves in a straight line, a simple push or a pull. Then you have rotary motion, which is exactly what it sounds like. It spins around, kind of like a wheel or a motor. And you can see that difference right here. The linear actuator, it's all about that straight line push-pull action, like a rod extending out and then pulling back in. The rotary one, on the other hand, is built to spin something, like a shaft. Super simple difference, but it's absolutely crucial for how they're used.
All right, so the second way to categorize these things is by what powers them. And this is where things get really interesting and where you see all the variety. We're talking about actuators powered by everything from hydraulic fluid and air pressure to electricity, magnetic fields, and even just pure mechanical force.
So let's do a quick tour, right? We'll go through these power types one by one and see what makes each of them tick, and more importantly, where you'd actually find them in the real world.
First on our list are the real heavy lifters of the bunch, hydraulic actuators.
So these things are absolute powerhouses. They work by using a fluid that you can't compress, usually some kind of oil. A pump forces that fluid to move a piston, and because you just can't squeeze a liquid, you get an incredible amount of force out of it. We're talking about the kind of power you see in the massive arm of an excavator or what it takes to lower the landing gear on a huge airplane. That's pure hydraulic muscle.
Okay, next up we've got their close cousin, the pneumatic actuator.
Now, pneumatic systems are a lot like hydraulics, but with one key difference. Instead of liquid, they use compressed air, or sometimes a vacuum. This makes them super fast, really reliable, and often a lot safer and cheaper to run. They're perfect for jobs that need really quick, repetitive motions.
All right, now let's talk about the one you have almost definitely used already today, maybe without even knowing it, the electrical actuator.
If you could peek inside one of these, you'd see this whole little world working together. You've got an electric motor for the raw power, a bunch of gears to manage the speed and force, and then the circuit board that's basically the brains of the operation. It's pretty cool. This is where a tiny electrical pulse gets turned into super precise, controlled movement.
So how do they do it?
Well, at their core, most electrical actuators work by playing with magnetic fields and electric currents to create force. It's this simple principle that makes them absolutely essential for, pretty much all modern automation. We're talking everything from robotics all the way down to the tiny mechanism that focuses the camera on your phone.
Okay, so most electrical ones use magnetism, but some devices take it a step further and use it way more directly. And these are what we call magnetic actuators.
So with these, it's all about using magnetic fields directly to create force. And we usually sort them based on what part is actually doing the moving. Is it the coil, the magnet, or a little metal core? By controlling the magnetism this directly, you can get some unbelievably precise and super fast movements.
All right, last but definitely not least on our little tour, we get to what I think is the cleverest of the bunch, the mechanical actuator.
Now these are different. See, unlike all the others, mechanical actuators don't really create motion from scratch. Instead, what they do is they cleverly convert one kind of motion into another. Think about the steering in your car. That's a perfect example. You have a system of gears that takes the spinning motion of you turning the wheel and converts it into the straight line motion that actually turns your tires. It's just brilliant.
Okay, so we've been through all the different types. Let's zoom out for a second and look at the big picture here. What does all this really add up to?
Well, it means that from the teeny tiny little motors and servos you'd find in a hobby robot kit, all the way up to those massive, powerful pistons and heavy industrial machines, these things are literally everywhere. And each one is perfectly designed for its specific job, giving just the right kind of movement needed.
Look, if you remember just one thing from all this, make it this. Actuators are, quite simply, the muscles of our modern world. They're the part of the machine that takes the brains, the computer chip or the control signal, and turns its thoughts into actual physical action.
And that just leaves us with this really fascinating question, right? As we push forward with stuff like self-driving cars, more advanced robots, and even smarter homes, the job of these hidden muscles is only going to get bigger and more important. The next generation of actuators, they're going to have to be smaller, stronger, and more precise than anything we've ever seen. So it really makes you wonder, what's the next big thing that's going to depend